Illustrative Math, Unit 3, Lesson 13 is called Multiplying Complex Numbers. So our goal today is very simple. I can multiply complex numbers. Remember, if you haven't watched any of my other videos, or if you're just, kind of behind on things, a complex number is A plus BI. A is the real number, BI is the imaginary number. So it's like a real part plus an imaginary. So an example would be like -8 plus, 4i. That would be a complex number. The -8's the A, the real part. The 4i is the imaginary part. All right. Write each expression in the form A plus BI, where A and B are real numbers. Another thing, too, I guess, to review, if you don't remember, where does I come from? It comes from the square root of -1. And then I squared is equal to -1. How do you get that? Well, if you square both sides, the square gets rid of the radical, which would just mean I squared equals -1. All right. So this is going to be 12i squared. Replace the I squared with -1, so I get -12. So that's a real number, so then I would put plus 0i. This would be -12i squared, which would basically be -12 times -1, which would be 12. So that's a real. I need to add the imaginary part. So since I don't have an I just put 0i. This would be positive 10i squared. So it'd be 10 times -1, which is just -10. So really all these are going to end up getting you an I squared, which is going to give you the 0i. -25 I squared. So really it's -25 times -1. So we just get positive 25. And then we put plus 0i. This one's a little harder. -5 squared is really -5 squared like that times I squared. A lot of people screw up that negative sign, but it's really, it's going to be a positive 25 because -5 times -5 is positive. And then I squared's -1, so I get -25. Then I put my 0i, right? Because it says A plus BI. All right, take turns with your partner to match an expression in column A with an equivalent expression in column B. So let's see here. I'll just kind of go. This one looks simplified. This one looks like I need to do the simplifying. So this is going to be 35i, 5 times 7. So get rid of that. This is going to be 35i squared, which is 35 times -1. So that's just -35. Okay. This is going to be 3 times -1. So that's -3. This one here is going to be 9i squared. So it's 9 times -1, which is -9. This one's a little harder with the cubed. It's going to be 8. You got to write it as powers of I with powers of 2 and 1. So if I did I squared times I, that's still equal to I cubed. So then we know that it's 8 times -1 times I. So I get -8i, which is right there. I to the 4th. Well, you could think of it as I squared times I squared, which would be -1 times -1, which would equal 1. -I squared. So you got the negative sign there, and then I squared. So this is -1, so it's -1, which would be +1, which would be, oh, it's right here. That one has 2 answers, it looks like. All right. And then this one here, -I squared. So think of it like -1 squared times I squared, which would be, this is -1 squared is 1. I squared is -1. So that one is -1, which is right here. So it looks like I didn't use the 9. Oh, wait, I just didn't cross off the -9. Whoops. Did I get a 9 anywhere? I don't think I did. No 9. They want you to think this one's 9. They want you to accidentally square the 3. but we didn't do that. So this one doesn't get used, okay? All right, for each match that you find, explain to your partner how you know it's matched. So I kind of did that over there in the work. For each match that your partner finds, listen carefully to their explanation. All right, so I just kind of did all that in one step. All right, so now we're going to multiply complex numbers. So when we multiply, we've been doing them with the box method. So 3 plus 2i, negative 4 times negative 5i. So you multiply negative 4 times 3, gives me negative 12. Negative 4 times 2i is negative 8i. This is negative 15i. And then here you get negative 10i squared. So you got to simplify this. Remember, negative 10 is kind of like the last slide. I squared is negative 10 times negative 1, which is positive 10. So I'm going to cross that off, and I'm going to change that to a positive 10. So when I look at this here, these are like terms. Those are imaginary. And then these end up being real. So I can combine the real, combine the imaginary. So negative 12 plus 10 would give me negative 2. Negative 15i minus 8i is negative 23i. Okay. Over here, you can make another box, or you could just distribute if you want. I'll go ahead and make a box here if you want. It's really going to be a smaller box, though, because it's just 3 and 9i times 5i. So I get 15i and then 45i squared, which I squared is negative 1. So this ends up being negative 45. So my answer is negative 45 plus 15i. Now over here, a lot of people screw this up. A lot of people want to just like square each term, but when I have a plus sign, I have to multiply it out. So I make a box here. 3, 2i, 3, 2i. I get 9. I get 6i, 6i, 4i squared, which when I replace I squared with negative 1, I get negative 4. So these are my imaginaries, these are my reals. So 9 minus 4 would be 5. 6i plus 6i would be 12i. Okay. Over here. Now, some of you might remember the FOIL method where you take the first terms and multiply those. Let's do it that way instead of making a box. So 8, you could still make a box if you want, but I'm going to change it up just depending on how you learned it. 8 times negative 5 is negative 40. And then I got to take the 8 times the 3i, so that would be 24i. I times negative 5 is negative 5i. Then I times 3i is going to be 3i squared. Now, I squared is negative 1, so this is going to cancel, or this isn't, I shouldn't say cancel, this is going to turn into negative 3. So I can add the reals and then add the imaginaries, and I get negative 43 plus 19i. Over here, do it the same way. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i, and then this becomes negative 4i squared. So 6i, negative 6i plus 6i, that adds up to 0. This becomes negative 4 times negative 1. So this is a plus 4, so it's just 9 plus 4 would be 13. It says write it in the form a plus bi, so I'm going to say 13 plus 0i. All right, 2 plus I times 2 minus 3i is equal to 3 plus 2i plus 7 plus 4i. It says mentally, without going through all the trouble of writing each side in the form a plus bi, what about the structure of the expressions on each side of the equal signs tell you that the equation is true or false? Well, what about the structure? Well, I would say here that, you don't have to multiply the whole thing out. You could say here, like, the real part's gonna come from the 2 times 2, and then the one that'll give you the I squared. So you could kinda check out here, like, look at you don't have to multiply the whole thing out. You could say, "Oh, 3 plus 7." My real part's gonna be 10. If I come over here, I'm gonna get 4 when I do 2 times 2, and then this is gonna be negative 6 I squared. So that's going to be 4 plus 6. That's going to give you 10. So the real part checks out. We might actually have to multiply the whole thing out. If I want to do the imaginary parts here, this is going to be 6i. If I come over here, I need to do, oh, no, not that one. Whoops. I need to do the 2 times the negative 3. So when I get here, I get the negative 6i plus 4i. And right away I can see this is going to be negative 2i. I'm supposed to get 6i over here, so I can say it's false. So if I got it at the real part, I could have stopped and cut it a little short. All right. Here's another one very similar to that. So the real numbers over here is going to be negative 10 minus 4 is negative 6. If I go over here, I just need to multiply the reals and then the imaginaries, because that's going to give me a negative 15i squared. So this is going to be negative 15 times negative 1. So that's going to give me 9. I can see right away that they're not equal. So I would say that's false also. Okay. And I didn't have to multiply the whole thing out. All right. So I can multiply complex numbers. You can use a box or you can use the FOIL method, whichever you prefer. All right. Here's our cool down. So find the solutions to this. This doesn't really apply to what we did today, but square root both sides. So x equals plus or minus. So square root of negative 20 is going to be the square root of 20 times I. All right, now our book, this illustrative math book, they leave it like that, which I hate that. It drives me insane. To me, the square root of 20 needs to be simplified. So you need to rewrite 20 as a product of two factors with one of them being a perfect square. So 4 times 5 gives me 20. So that's helpful now because square root of 4 is 2. So this would be the best answer because this is simplified. Now, if I type in the square root of 20 to my calculator and I type in 2 times the square root of 5, I'm going to get the same number. It's a decimal, it's rounded, but it's kind of like this is a reduced radical and this is not reduced. It's kind of like, if you had like 10 over 20 as your answer with a fraction, if you circled that, that's right. It's not wrong, but the best way to write it would be 1/2. You would want to reduce it. That's what we prefer. Same idea with radicals. You always want to simplify a radical if you can. So that's definitely a something that's not done well in this textbook, but whatever, it is what it is. I would, I guess I'd take either one of those, but you take the ACT or something like that, you probably see it written like that. So next one, negative, square the 7, square the I. So 49. So negative 49 times negative 1 is 49. I guess maybe I should write it in the A plus BI. So this write it as an integer. Oh, okay, so I guess I don't have to write in the A plus BI. It says write it as an integer or a multiple of I. If I wanted to write these as reals plus imaginary, I could write it like that. I could split it up into two separate ones, or I could just be lazy and use the plus or minus. This would be 49 plus 0i. All right. Hope you enjoyed this video, and thanks for watching.